The next example I want to work with is like a real scatter plot. I mean, I used essentially a scatter plot function to make the graph that's showing on the screen right now. But of course, you wouldn't think of this as a scatter plot. This is a plot. This is, I don't know what I would call this. This is a plot of the means of each of these dog types with some gray dots indicating the frequencies of each of the WAG counts for each type next to the means. But a conventional scatter plot has numeric data on both axes. So let's try one of those. Here I'm going to plot Borks against WAGs. Yeah, I had to be a little playful with this one because, I don't know, I was just in a different mood when I created it. Oh, I'm actually going to close this plotting graphics device because PAR, when I called it before, readies a graphics window like this, graphics device, in at least in the default R installation, and that will continue to be the active window even when I generate new plots unless I close out of it. So we're getting a fresh start here. I'm creating this scatter plot with Borks and WAGs. This is the simple version of that scatter plot. I have this formula, Borks on the y-axis, WAGs on the x-axis, and I'm specifying where the data are coming from. So I'm going to do the same thing I did before where I add bits and pieces to this plot as I go. I'm doing more at once here. So in this next step, I'm calling par again with special margins for this type of plot. 4 lines on the bottom, 3 on the left, 1 on the top and 1 on the right. And I'm going to plot the same data again, but now I'm going to specify the x limits should be from 0 to 45 instead of like a little less than 15 to like 44 or whatever that is. The y limits should be from 0 to 18. The X label should be WAGs with a capital W, and the Y label should be Borks with a capital B. I'm going to use plotting character 16. I'm going to use this color, which is black, except with this degree of transparency. Now I'm using 5-0 instead of 2-0, just because there's going to be less overlapping points, so I want them to be a little darker to begin with, so they'll be visible. And I'm going to use this MGP and TCL same argument from before because I think it generates prettier margins and ticks. So here's that version of the scatter plot. And there are those gray points, right? They're darker where more points overlap. This shade of gray you see on the points in the extreme upper right and lower left, that's the lightest it gets because I specified 5-0 for the degree of transparency or opaqueness. And so they're just a little more shaded by default because I have less overlap. And so I didn't want them to be so light they would be hard to see. It makes sense there's less overlap because now there's 2 numeric variables. They're still sort of discrete because they're counts. I mean, this is fake data, but in principle, these are counts of the number of Borks and WAGs that each of these types of dogs did in some study or situation. But there's many more possible values than there were for type of dog, which only had 4 possible values. So now that I have this scatter plot with discrete points plotted, I might also like to have a regression line. And so I'm going to use AB line to plot that. And the line is going to be based on the linear model with the same function that I used for the plot in the first place, Borks tilde WAGs, and the same data set. So there's that regression line. That regression line extends all the way across the entire range of the plot, which is okay. It gets the point across. But maybe I would like to have the regression line only show up within the range of the data to help emphasize that it's not usually a good idea to extrapolate beyond the range of the data. Here's a version of the scatter plot that does that. This par line is the same as before. It sets up the space to graph in. I'll show you from nothing. Sets up a space to graph in that does not have any plot in it yet. This plot function is the same as before. It generates this plot with these gray dots. The next thing is different. I am calculating this linear model, this regression model, and storing it in a variable called mod. So this doesn't affect the plot at all. I'm just keeping track of my regression model so that I can refer to it later. And then I am calculating and keeping track of some other information that I might like. So I'm going to minimize the plot for a second so you can see this. This variable min-max WAGs is going to contain the minimum of the WAGs variable, ignoring missing values, and the maximum of the WAGs variable, ignoring missing values. Both of those are going to be calculated with DAT, so I don't have to do DAT $ each time. Again, not necessary in this case, but sometimes helpful. And I put the whole line of code in assigning that value to min-max wags in parentheses, so we'll also see the result. 14 is the minimum, 43 is the maximum. Min-max wags is a vector that contains those two values. Fitted Borks is also going to be a vector. This is going to be the result of the predict function that uses that model. So it is predicting points based on that model with the new data equal to a temporary data frame that has one variable in it called wags and has only those two values, the minimum and the maximum of wags. All this is doing is taking the minimum wags and maximum wags from the data set and plugging them into the regression model in order to get the fitted values at the minimum and the maximum. So fitted Borks has two values, starting at 8.95 and at 15.18. Given that information, I'm going to draw some lines on this plot that have x coordinates, min-max wags, and y coordinates, fitted Borks. The width of the line is going to be 2, the color is going to be blue. There it is. The function is still called lines. In this case, I only drew one line. So there's that regression line set up so that it only extends through the range of observed data. Another way that you could do a scatter plot so that you would be able to show points that overlap in a sensible way is to add jitter. This version of the scatter plot, I just ran the par, so that set it up with the margins like I had before. This version of the plot, I didn't build up step by step, but the x-axis is going to plot dat $wags, but it's not going to plot the raw values of dat $wags. It's going to plot the result of the jitter function on dat $wags with amount equals 0.3. That's the amount of jitter I want to add. It's just going to purposely add random noise to the wags variable so that the points won't all show up on top of one another, but just a little bit of random noise so that they'll still show up near one another when they're supposed to be on top of one another. The same thing for the Borks variable on the y-axis. Here I'm not using a formula, I'm just having the x coordinates first and the y coordinates second with a comma in between them because they're separate arguments. The rest of these arguments are the same kinds of things you've seen before. The difference here, the color is just black instead of the shading thing that I did. So here's what that looks like. These are those same points that I plotted before, but now they're just jittered a little bit instead of shaded so that overlapping points are darker. I could, by the way, have used the RGB value for black instead here without any shading. That would have worked exactly the same. It looks different because the jitter is being generated randomly each time. $000000 represents 0 red, 0 green, 0 blue, which is black. Or you can just use the keyword BLACK, which represents that color. On top of that plot, I'm going to add the same line from before. So there's that blue regression line, just as before. So this is just another way of generating a scatter plot like this. Instead of shading them by how many points, plotting the points in their exact locations, but shading them by how many are there, I'm plotting them slightly off from their exact locations so you can still get a sense of how many are clustered near each other. Maybe I would do a version of that where I would like to color code them by type of dog. So this is something that would have been a little less intuitive with the shaded version of the plot, but with jitter it works fine. So this is exactly the same plot, but instead of color equals black, it's going to be the color equals dat $type. Dat $type is a factor, which means that although we think of it as Basenji and Beagle and so forth, R is stored as 1, 2, 3, and 4. That's what a factor is. And it turns out that colors in plotting, you can use 1, 2, 3, you can use integers to represent preset colors. So if I assign the color to be whatever the factor level is, 1, 2, 3, or 4, when I call this plot function, then it will give me black, red, blue, and green points representing those 4 categories of dog type. I don't actually remember the order that the colors are, 1, 2, 3, and 4. I know black is 1, but I think it's black, red, blue, green. It doesn't matter because I'm about to add a legend that will help clarify. Um, and I'm also going to, so that's just a cheap way to quickly get a plot that's color-coded by type, knowing that black, red, blue, and green represent distinct factor levels. But if I'm making this plot to share with people, I'm probably going to want to choose my own colors instead of just using the ones that R has numbered 1, 2, 3, and 4. So I'm going to redo that scatter plot color-coded in a way where I'm more intentional about my color choice down here.